Hello everyone, welcome back to our channel. In today's video, we are going to discuss Introduction to Statistics. So obviously, this lesson is part of our subject entitled Probability and Statistics. Now, before we are going to proceed to our discussion, I have here a quite funny quote about statistics. Here it goes. There are three kinds of lies. Lies, damned lies, and statistics. Okay, so why or what do you think are the reasons why we need to study statistics? Now we have here the list why study statistics. Number one, we have here data are everywhere. Number two, we have statistical techniques are used to make many decisions that affect our lives. Number three, no matter what career, you will make professional decisions that involve data. An understanding of statistical methods will help you make decisions effectively. Now, there are applications of statistical concepts in the business world. Why do we need to study the applications, or why do we have to mention about the applications when we are going to study probability and statistics? Now, it is because most of the students, if not all, but we know for sure that majority of the students are really not into mathematics. They find the subject difficult. They find the subject complicated compared to the other subject areas. Now, by simply understanding the importance or the applications in the real life situations or scenarios, students or you or us would tend to embrace our love, our passion towards the subject. Okay, so going back, let's discuss on the applications of statistical concepts in the business world. Let's start with the finance. How is statistics used in finance? You have here correlation and regression, index numbers, time series analysis. Let's proceed to marketing. We have hypothesis testing, chi-square test, non-parametric statistics. We also have personnel. We still have hypothesis testing, chi-square test, non-parametric test. How about in operating management? We also have hypothesis testing, estimation, analysis of variance, time series analysis. Now this we have mentioned are the statistical concepts that you will be learning as we go through with our discussion on the next videos. Now, what is then statistics? Or what is the definition of statistics? Now, statistics is actually the science of collecting, organizing, presenting, analyzing, and interpreting data to assist in making more effective decisions. Statistical analysis is defined or is used to manipulate, summarize, and investigate data so that useful decision-making information results. Here's a picture of statistics. Is actually a bunch of numbers looking for a fight. So that is just a quote. Now, let us proceed. What are the types of statistics? Now, basically, we have here the two types of statistics. We have the descriptive statistics and inferential statistics. I think you have learned this in your junior high, that we have two types of statistics. What is then a descriptive statistics? Now, a descriptive statistics, it involves methods of organizing, summarizing, and presenting data in an informative way. However, we have here inferential statistics, the methods used to determine something about a population on the basis of a sample. Now, what is a population? Now, the population is the entire set of individual or objects of interest or the measurements obtained from all individuals or objects of interest. Take a look at the diagram. If you have here the population that actually involve all items. Okay, we have the figures of cars in there, and then if you're going to get a sample, you have there the items selected from the population. So there is a representation of a population that would be the sample. Then let's proceed to inferential statistics again that involve estimation. The example of estimation we have here, estimate the population mean weight using the sample mean weight. Okay. Then we also have hypothesis testing. An example of it will be test the claim that the certain weight of a particular group of people is this one, let's say 45 kilograms. Now, inference is the process of drawing conclusion or making decisions about a population based on a sample results. Now, what is sampling? Now, sampling is a word that is often or commonly used in the field of statistics. Now, sampling, you have here a sample should have the same characteristics as the population it is representing. Now, the sample can be, it could be with replacement. A member of the population may be chosen more than one, meaning picking the candy from the bowl. Okay? Then it could be without replacement, meaning a member of the population may be chosen only once. For example, will be the lottery ticket. Now, there are kinds or there are methods in sampling, or we call it sampling methods. Sampling methods can be random, meaning each member of the population has an equal chance of being selected. Okay, and the other one is non-random. So that's actually the opposite of random. Now, the actual process of sampling causes sampling errors. Now, for example, the sample may not be large enough or representative of the population. So factors not related to the sampling process cause non-sampling errors. And a defective counting device can cause a non-sampling error. So let's proceed to the random sampling methods. There are 4 methods for random sampling. The first is the simple random sampling, which means each sample of the same size has an equal chance of being selected. We also have stratified sample, meaning we divide the population into groups called strata and then take a sample from each stratum. Stratum, by the way, is the singular form of strata. Then, third is cluster sample. Divide the population into strata and then randomly select some of the strata. All the members of this strata are in the cluster sample. Now, the fourth one is systematic sample. Randomly select a starting point and take every nth piece of data from a listing of the population. So that's systematic sample. Now, for descriptive statistics, this is usually done like collecting the data. As you can see, the example is survey, wherein the researchers may probably float questionnaires to their respondents, then present the data in tables and graphs, then summarize the data. Now, what are statistical data? You have here the collection of data that are relevant to the problem being studied is commonly the most difficult, expensive, and time-consuming part of the entire research project. Now, statistical data are usually obtained by counting or measuring items. Primary data are collected specifically for the analysis desired, and the secondary data have already been compiled and are available for statistical analysis. Now, a variable is an item of interest that can take on many different numerical values. Now, what is data? You have here statistical data are used obtained by counting or measuring items. Most data can be put into the following categories, and there are two. So we have here qualitative and quantitative. So for the qualitative, we have data or measurements that each fall into one of several categories. Examples, we have hair color, the ethnic groups, and other attributes of the population. For quantitative data, we have here data or observations that are measured on a numerical scale. Example, the distance. You also have number of children. Okay. For qualitative data are generally described by words or letters. They're not as widely used as a quantitative data because many numerical techniques do not apply to the qualitative data. For example, it does not make sense to find an average hair color or blood type. For qualitative data can be separated into two subgroups. We have the dichotomic and the polynomic. Now, what is dichotomic from the term there, or let's say the prefix di? If it takes the form of a word with two options, example, gender, we have male or female. Okay, so probably before it is applicable, but now we have other examples of or other options for gender. Now, we also have polynomic. If it takes the form of a word with more than two options, like education, because education has more than two options. We have primary school, secondary school, and university, or even college. Now, quantitative data are always numbers and are the result of counting or measuring attributes of a population, from the word quantity. Quantitative data can be separated into two subgroups. We have the discrete and the continuous. Now, for the discrete, if it is the result of counting the number of students of a given ethnic group in a class, or the number of books on a shelf. Okay, that is an example of discrete quantitative data. Now, for continuous, if it is the result of measuring distance traveled or weight of luggage. Okay, so if we are going to present the types of variables on a chart, it would look like this. The variables on top, then we have the two types of variables. We have the qualitative and then quantitative. Under the qualitative, we have the dichotomic and the polynomic. We have example of dichotomic, we have gender. For polynomic, we have brand of PC or personal computer, then hair color. Then for quantitative variables, we have two types. We have the discrete and the continuous. For the discrete, we have examples, children and family, strokes on a golf hole. And for continuous, we have amount of income tax paid, weight of a student. Now let's proceed to the numerical scale of measurement. So we have here the first one. The first one is nominal. Now, nominal consists of categories in each of which the number of respective observations is recorded. Now, the categories are in no logical order and have no particular relationship. The categories are said to be mutually exclusive since an individual or object or measurement can be included in only one of them. Now, for ordinal, we have contain more information, consists of distinct categories in which order is implied. Values in one category are larger or smaller than values in other categories. Examples, we have rating excellent, good, fair, or poor. Then we also have interval. It is a set of numerical measurements in which distance between numbers is of a known constant size. Okay, so that is interval. And we have here, the last one is the ratio. Now, pardon me, it's not so clear on the video, but the ratio is, you have here, consists of numerical measurement where the distance are in a ratio form. Okay, now take a look at the picture. Yeah, I don't know how to do statistics, but it doesn't matter because I didn't have data. Because obviously, it's the data that we need to use in order for us to come up with decisions. Okay, which involves statistics. Now, let us proceed to data presentation. Now, for data presentation, we have here numerical presentation of data, qualitative data. So we have pivot table. We also have contingency table. For pivot table, we have the qualitative dichotomic statistical attributes. Contingency table, we have qualitative statistical attributes from which at least one of them is polynomic. Since you know already what's dichotomic and polynomic, then you should know how to convert absolute values relative to relative ones. I think you're also familiar with frequency distribution table. So that involves frequency distributions, numerical presentation of quantitative data. Now, what is frequency distribution? It shows the frequency or number of occurrences in each of several categories. Now, frequency distributions are used to summarize large volumes of data values. When the raw data are measured in a quantitative scale, either interval or ration categories or classes must be designed for the data values before a frequency distribution can be formulated. Now, charts and graphs. Let's start with histogram. It is frequently used to graphically present interval and ratio data. Is often used to interval and ratio data. The adjacent bars indicate that a numerical range is being summarized by indicating the frequencies in arbitrarily chosen classes. Now, have you seen an histogram already? So let's have an example. So this is an example of histogram where the frequency is on the y coordinates, or y-axis, I mean. And the income in thousands of dollars is on the x-axis. So that is an example of a histogram that summarizes the executive incomes for the Sunrunner Corporation. Now, let's proceed to frequency polygon. Another common method for graphically presenting interval and ratio data. To construct a frequency polygon, mark the frequencies on the vertical axis and the values of the variable being measured on the horizontal axis, as with the histogram. Now, if the purpose of presenting is comparison with other distributions, the frequency polygon provides a good summary of the data. Let's have an example. Now, we have here a frequency polygon of executive incomes. So, on the y-axis, you have there the frequency. On the y-axis, you have the income in thousands of dollars. So, some or most of the students would be confused as to the difference between a line graph and a polygon. So, just bear in mind, since it is called frequency polygon, we know already that a polygon is a closed figure. So as you can see, it's a closed figure. Okay, so let's proceed. Next would be Ogive. Now, a graph of a cumulative frequency distribution. Ogive is, others pronounce it as Ogive, okay, is used when one wants to determine how many observations lie above or below a certain value in a distribution. The first cumulative frequency distribution is constructed. Then cumulative frequency are plotted at the upper class limit of each category. Now, Ogive can also be constructed for a relative frequency distribution. That is an example. An example of Ogive of an executive incomes. You have the frequencies. You have number on the y-axis and income in thousands of dollars in the x-axis. Okay, proceed. Let's proceed to pie chart. Now the pie chart is very common. The pie chart is an effective way of displaying the percentage breakdown of data by category. Now, useful of the relative sizes of the data components are to be emphasized. Pie charts also provide an effective way of presenting ratio or interval scale data after they have been organized into categories. Example, you have it here. Example of an expenditures of funds for iTrix company presented using a pie chart, where we have here the legend on the right side. We have the wages, the raw material, shipping, overhead, and miscellaneous. So that's a pie chart. Let's proceed to the next. The next one is bar chart. Now, another common method for graphically presenting nominal or ordinal scale data. One bar is used to represent the frequency for each category. Now, the bar are usually positioned vertically with their bases located on the horizontal axis of the graph. The bars are separated, and this is why such a graph is frequently used for nominal and ordinal data. Now, the separation emphasizes the plotting of frequencies for distinct categories. Example, we have an example of bar chart here of favorite colors of 32 people. So you have the numbers or the frequency on the y-axis, and we have the favorite colors on the x-axis. Okay, let's proceed. Now, let's proceed to the time series graph. Now, the time series graph is a graph of data that have been measured over time. The horizontal axis of this graph represents time periods, and the vertical axis shows the numerical values corresponding to these time periods. We have it here, the time series graph of corporate revenue, Flightcraft Corporation. So we have on the y-axis millions of dollars, and the year on the x-axis. Okay, so that's the time series graph example. Okay, so before we proceed, let's take a look at this picture or pie chart. What I do when a teacher says this cannot be done the night before. You as a student, how would you respond that? So you have there the legend who chose the dark blue, adhere the warning and start early, or the one with red color, take it as a personal challenge. Okay, so majority of the students chose red, take it as a personal challenge. Okay. Most of the students, human as we are, we love challenge. Now let's proceed. For me to check your comprehension, so I have two sets of activities. So activity 1, I want you to answer these questions. I'm gonna read each question. Okay, so I'll get question number 1. What does the term discrete data means? Question number 2. Write down 3 examples of discrete data. Question number 3. What does the term continuous data mean? Question number 4. Write down 3 examples of continuous data. Question number 5. For each of the following, state if the data would be discrete or continuous. So all you have to do is choose whether the data or the following data is discrete or continuous. Letter A, the number of people in a room. B, the number of pages. B is, for a moment, the number of books. The mass of a book, mass or weight. Then letter C, the number of pages in a book. D, the length of a line. E, the time taken to complete a puzzle. F, the size of a shoe. G, the number of glasses in a dishwasher. H, the volume of water in a bottle. I, the number of songs in an album. J, the weight of an apple. K, the number of people at a football match. Then question number 6. A teacher collects the ages of students in her school. Is that variable discrete or continuous? Question number 7. Stephen keeps a record of the prices of all the cars he sold in 1 year. Is that variable discrete or continuous? Okay, so let's proceed to activity number 2. Define statistics and cite at least one of its applications. Enumerate the sampling methods. Enumerate the different ways on how the data can be presented that has been discussed, and present the types of variables using a diagram. Okay. So I think the 2 activities are clear enough. And you may now start answering. Now let us proceed to a quote, okay, for today. Without mathematics, there's nothing you can do. Everything around you is mathematics. Everything around you is numbers. So thank you so much for watching, and make sure to answer the 2 activities. And please don't forget to subscribe the channel. Bye!